Hello everyone. Welcome to another episode. Uh, this is yeah, it's kind of funny. Let me see. Please confirm that you can hear me because I have just changed something and apparently it stopped working 2 minutes ago. So I'm not sure if you can hear me. Please write somewhere in chat that you can hear me. It's kind of important. So let's see. Yes, I need to hear some confirmation that good sound is good. Apparently there is some delay somewhere, but at least now I should not have big problem with my laptop fan, because on this laptop there is no fan. I think Apple forgot to put it. Okay, so let's get started. Today's episode is going to be a little bit different from me just talking about different random stuff because, well, um, I will be talking about Spacelift, and I will not be talking about Spacelift from like traditional point of view where I talk about just random things, and hopefully you guys understand what I'm talking about. This time I want mm, to kind of put some context to why I do this and what's actually going on. So some of you may know that, I've been with Terraform ecosystem or within Terraform for, well, more than 4 years now. And half year ago, I posted this message on LinkedIn where I said that it's really surprising to me that Terraform AWS modules are being used like very actively, and there was no single attempt by any Terraform automation SaaS to provide their services for Terraform AWS modules open source for free. Of course, there were some companies who reached out and say like, oh, you can just buy a license and use it for your stuff. Well, that's not exactly what I want to do. I develop a lot of open source things, and this is just an excellent opportunity to show how different Terraform automation platforms can be used to manage open source stuff for real. And after some time, I talked to Spacelift, and they just proposed to use their service to show how it can be used to manage some features of other open source projects. And that's how it started, right? So currently I joined Spacelift as a very short short commitment from my side as an advisor. So I will try to provide feedback to them and explain how people are using Terraform and automation and so on. And hopefully we'll build Spacelift together better. But once more, I asked this question a long time ago before I joined as an advisor. So the stream which I want to have today is not me saying how good Spacelift is and everybody should be using it. Obviously, it's not. I mean, there are a bunch of different products. I'm not going to sell you anything. I just want to use it for my real stuff, which is Terraform AWS modules, and specifically meta configurations for all of them, where we manage teams, permissions, labels, and so on for many other things. So so here was it. So that's just a little kind of explanation that how I ended up interacting with Spacelift. In the past, in November 2021, November, right before AWS reInvent, I did already review Spacelift, and I looked into the system and kind of figure out how things were working, how things were not working, what was confusing. I provided some feedback to them. So I already looked into the system, but this time I want to do it a little bit more end-to-end. And I scheduled this review for for 2 episodes. So this week and next Friday, I will try to cover it in more details. But actually, more I was preparing for this episode, I started to feel that I don't understand what I'm going to talk about, because the platform itself is so big, and I'm not an expert of this platform yet myself. So I need to I need to kind of set the expectation that during this week and during next week there will be mixed levels of information. Some of this may sound obvious and you already know it. Well, that's good. But some of this information may be not so well polished from my side, because I don't know yet how this is supposed to be used. So if you have any questions about using Spacelift, like for real, don't hesitate to reach out them to, well, they have a new website, spacelift.io, and ask any questions. I'm sure that there are a lot of people, well, there are quite a lot of people within Spacelift who can answer your questions and explain how certain things were designed and why you should be using them. So I'm not going to answer so many questions myself right now, but I believe there are some employees by Spacelift in the chat, so feel free to ask your questions there, and well, they will be able to help you anytime as well. So without further ado, let's go to where? Right, let's close this LinkedIn. And another announcement which I want to make is, when is it? 17 and 18 of May, we will have DevOps Days Ukraine, which will be online, and it's going to be an awesome DevOps Days as usual. We actually didn't plan to have it online, but for obvious reasons we're going to have it online, and we want to raise much more for Ukraine, because, well, there is a war in Ukraine, and if you like this conference, you can go to DevOpsDays.com.ua, donate something, but of course you will not just donate something, you will actually see a lot of interesting people talking about very interesting topics. So as you can see, well, some of these faces you're already familiar with, right? You know this guy. Right. What I'm going to talk about is definitely about Terraform, but I don't want to reveal exactly what is it, because I have no clue what is it going to be. But I will come up by this evening with the subject and talk itself. So, well, a bunch of different people, and yeah, it's very cool. I mean, even for me, I have not met these people for quite a while. So feel free to go to DevOpsDays.com.ua, and you can also submit your Ignite talk here, or you can send an email, or you can contact me if you have any questions. So let's get going. So what we will learn today. Okay, so the first thing, well, actually I have notes for today, which is very unusual for my live streams, because I actually spent significant amount of time preparing for this. So what we will learn today, we will look into the basic of Spacelift, and we will see like some things here in documentation, and I will explain basics of it. And the main part here will be actually what I initially planned. Well, we have this Terraform advanced modules meta repository, which is 2 years old, but it's a little bit messy and a little bit unstructured. It's not very well written, I would say, because, well, I didn't think about how to write it best. And it's very complicated for me to explain many different peculiarities of Terraform. So what I did, I mean, forget this one. I made another one, which is spacelift-meta, which is exactly the same content of meta, where you have GitHub folder, And then you have main folder, and this is configuration for one single repository. And as you can see, I'm managing another repository, not Terraform AWS modules, just because I don't want to destroy anything there and then people suffer, and well, it will be not nice. So bear with me that it's another repository, but the flow is the same. I'm going to use Terragrunt for that, and this is repository configuration. I'm using this module, which is local, and I'm going to provide these inputs to it. So pretty much the same flow as I have in the main meta repository, but it's much smaller than the main meta one. What else do I have in this repository? Well, there are modules. As you can see, this is very simple way to manage GitHub issue labels for specified repository. Again, this is not rocket science, and we'll kind of increase this complexity, and probably next time it will be real stuff with more fancy GitHub resources. So what else do I have here is another Spacelift Terragrunt folder. So this folder is where I have the configuration for the Spacelift. Stay tuned, I will click here a bit later. It's just a little bit too complicated right now. So this is configuration for the Spacelift itself, and well, and that's it. And one more thing which I want to make sure that everybody understand, and especially people who think that, oh my God, Terraform AWS module suddenly will be affiliated with Spacelift in any way. No, it's not going to happen. Terraform AWS module is still an open source project. It has zero affiliation with pretty much anyone, you know, other than the community itself. So don't worry about that. We're not going to integrate it so heavily, though it has some interesting option to do that as well. So for the time being, Terraform AWS modules will not have anything else than just this meta repository integrated with Spacelift. Okay, so a couple things related to where to find different information about Spacelift. Well, I'm glad that you asked this question. First of all, very good question. And Spacelift documentation is here, docs spacelift IO. You can click here, you can read it. It's very well structured and very easy to follow as well. What we're going to go through today is pretty much main concepts as well as Terraform specifics. So that's pretty much it. And another very interesting piece of content which I really like to read from time to time is spacelift.io/blog. Why do I like to read it? Well, because there are a lot of interesting topics covered, not necessarily about Spacelift. Well, actually, I don't think there are topics talking about how Spacelift is implementing certain features here. Well, maybe it does, but in general, it has quite good variety of different topics on general subjects, as well as different comparison, different features of different tools, some misinformation, I think in this article, but it's okay. And if you click on load more posts, you will see that there are even more posts. So there are a lot of different articles you can read. Yeah, so if there is product, then it's talking about Spacelift features, but in general, it's very broad and very good type of content for education. Yeah. Oh, by the way, I can see chat. Oh my God, that's so cool. Yes, hello everyone. Oh, well, hello Valid. Hello Ronaldo. Okay, yes, so let's just make sure that you read this blog post from time to time. I think you can subscribe here, but you can also subscribe on RSS, I guess. Anyway, it's a very good starting point if you're not familiar with DevOps, Terraform, Ansible, Pulumi, what is what. So take a look there. Okay, well, in my to-do list, we're already on step number 7, which is amazing. And my step number 7 says that let's start with this docs. So what it means is that this documentation is very well organized. And if I go to, let's say, getting started, introduction to main concepts, you will see pretty much what is Spacelift. I'm gonna to repeat just basics of this one, and we move on to more complicated topic where actually, well, that's the whole point. So the main concept is the following. Well, there is stack, which is kind of obvious, right? It's central entity. It connects version control system and manages state of infrastructure. So that's what we're gonna to operate with. So it's called stack. And policies is another very powerful concept. Policies in Terraform, or not in Terraform, in where is it? Well, overall policies are allowing users to control certain flows and express rules as code. These policies are written using Open Policy Agent, and we'll talk about this a little bit later. But think about this as a very powerful way to express rules as code. Well, if it says, well, I'm glad that it doesn't say that OPA is simple, because it's not simple to my mind. But sometimes people say like, oh, OPA is easier, OPA is simple. No, OPA is powerful, but they're not simple. So, yes, okay, so what else? Change workflow. Yeah, that's another very powerful kind of, not powerful, but well, this is very important to understand how change will be executed, or how overall Spacelift will be executed. So first of all, of course, it is deeply integrated with your version control system. Like in my case, it's going to be public GitHub. And there are ways to trigger Spacelift on pull request. And I will show this in detail a bit later. But most importantly, Spacelift takes care of your version control system push events, and it can dispatch it, and it can analyze them and do something accordingly. This is thanks to policies. Okay, well, express, yeah, right. Okay, if you want to do kind of things yourself, step by step is very easy concept. Yes, it requires pretty much 15 minutes of your time, and you will have things up and running. So first, stack run, that's what you can do here. You set up an account, you connect it to your GitHub repository, you create your first stack. As you can see by clicking buttons, is it good or is it bad? Well, let's decide it a bit later. Sometimes you need to click buttons before you can understand what are you gonna to do. But I will show how to do many of these things, actually pretty much all of this, without clicking buttons, but using Terraform provider for Spacelift. So you can click buttons, fill in different forms, create stack, and trigger your first run, wait for some seconds, and then change will be applied. So very straightforward flow, right? You connect it, you trigger run, wait for some time and things are created. Once you do this, you will become familiar with basics of it, and that's pretty much it. So now let's talk about our use case. So what we have in Terraform AWS modules meta is Terragrunt. Terragrunt is by definition a little bit special case. Why it is special? Well, just because Terragrunt concepts are not very much aligned with any Terraform automation system, because this is like extra utility on top of Terraform. So all Taco system handle Terraform pretty well, but Terragrunt is a rather special case. And the way how Spacelift implement this is quite simple. Pretty much all you need to do is to specify that your stack has label Terragrunt, and that's it. Then instead of Terraform, it will be calling Terragrunt. In theory, that's simple. But in reality, a lot of functionality which is provided by Terragrunt is already available in Spacelift, but using different policies or different types of policies. So that's why it is not really 100% implemented. It works well, but still sometimes it feels that it's unnecessary. So Spacelift plus Terraform can do exactly the same what Terragrunt can do, but it requires a little bit magic. I will try to show some of this, what I learned so far, and I'm sure that people who are using Spacelift with Terragrunt did significantly more than I could learn so far. So it will be, probably interesting to hear their opinion. Okay, so what else? Right, policies. Let's see, policies. Is this? Yeah, okay. No, actually, before policies, I need to show how the configuration looks like itself. So let's go to this one. Yeah. Okay, so here on the left side, you can see spacelift-meta, which is a repository which I just showed. And this is a folder where I have GitHub, which is Terragrunt project with two projects. One is called GitHub, where I have just root configuration for global things related to remote state and some generator just for fun. And then there is another one which is inside of main, which contains the main thing itself, right? So here I'm calling module and providing some inputs. So this is typical Terragrunt project. There is no need to make it really complicated for the purpose of this live stream, and I think you will be able to see certain features which I implemented quite easily. What I'd like to show now is Spacelift Terragrunt folder. So what this folder is, it contains Spacelift Terraform provider, which is configuring Spacelift stack. So the way how I did it, well, it's a little bit dirty, and I think next time I will make it a little bit more dynamic because I use it in another project. But nevertheless, what's going on here? We have all activities, and imagine that everything is happening inside of GitHub folder where people will open pull requests, will provide new changes, will add repositories, will change labels, or do whatever they want. And then we have to have kind of unknown amount of Spacelift stacks. And Spacelift stacks here, I'm generating based on Terragrunt folders which were discovered. So this is very rough implementation, which is not very perfect, but it works well for this case. So what I do here, I'm looking for all Terragrunt HCL files inside of GitHub location. Then I remove folders Terragrunt cache because, well, they are not needed here. And then I also make Spacelift stacks for each of this folder. So what it means is that there will be 2 stacks created because there are 2 folders with 2 Terragrunt HCL files. And name of this one is related to the location of it, as well as project root. Project root is where Spacelift will be checking for changes. Think about this as if we change something outside of a certain project, we don't really care about it, right? Of course, we can customize it like I do here. I add label for this stack where I specify that GitHub main, actually this one, depends on GitHub, which is this stack. The reason why I do this is because I want Spacelift to do similar logic as we have been able to have in Terragrunt if we specify dependencies, right? If we write dependencies and then something here, and then not dependencies, probably list, and then something here, right? So here it should be GitHub, something like that. So this functionality is useful in Terragrunt, and we use it quite frequently when we run Terragrunt apply all, and that's not gonna to work with Spacelift, not with any other provider, because it is another command which is not natively supported by Terraform. So that's why I add this depends on. In real projects, I actually generate this depends on dynamically based on information which is specified inside of these dependencies. Let me just show how to do this. Terragrunt. It's kind of not related, but still, it's kind of cool. What is it? Yeah, well, Terragrunt render JSON is almost block dependence. Yeah, okay. Dependencies. It should be something else. Maybe pass equal something like that. No. Well, I forgot the syntax, but anyway. The point is that Terragrunt. Well, how to do that? No, it should be quite simple. Let's see. Let's look into a real stack just for fun. And no dependencies. Well, anyway, that's not the point which I wanted to make today, but imagine that the right way is that you have your Terragrunt project and you've been using it forever, and you used features of Terragrunt. So what we need to do now is that we need to instruct Spacelift to make oh my god, what is it? Super sticker. That's kind of cool. I don't know what it means, but yeah, thanks. Okay, pink hat. Well, okay. All right. Hello from München. That's great. Now I understand. Okay, so what I wanted to kind of show is that this information about dependencies you already specified inside of Terragrunt HCL using dependency or dependencies block. So we need to instruct or we need to use Terragrunt details to configure Spacelift stack. So now let's just go and run this. No, this is not right. Folder, Spacelift Terragrunt. So here I have main TF, so I can just call Terraform apply just to show that this project I have executed before. So I made a couple stacks here, as you can see, for GitHub main and for GitHub. And I also, well, here you can see that I guess nothing special is here. Manage state is kind of relevant because I don't want Spacelift to manage state for me because I already do this myself, and I configured my Terragrunt to handle state for me. That's what I have this remote state for, and it knows where it is, how to access it, and so on. So another resource in this set is association of role I ran. So what this role I ran is, I made it outside of this project, and I explicitly allowed Spacelift to log into, well, to do certain things in this AWS account where I keep state. So this role configuration is allowed to be invoked by Spacelift using certain external ID, and it also has permission to access my S3 bucket and DynamoDB table because Terraform will be executed by Spacelift. And this is the most interesting part, right? Policies, as I said earlier, are essential part of controlling the flow inside of Spacelift, and I'm using, well, module. Of course, there is module. Well, why there shouldn't be any module, I don't understand. So yeah, there is a module provided by Spacelift, and this module, as you can read just by name, it is ignoring changes outside of project root. The source of this policy is located here. Ignore changes outside. Well, suddenly there are no colors in it. No, there are some colors, but well, that's not enough. Anyway, yeah, there are plugins for IntelliJ for Open Policy Agent, but I think previously I used Visual Studio Code to work with OPA. It had a pretty much similar interface. I could run these policies, and I can click somewhere here to run it, and well, it is a little bit easier to debug. Overall, policies, as I said, allow to control many different things. So this is a policy which is going to be invoked during git push operation. So when something is pushed to repository, this policy will be executed, and it will simply ignore changes outside of project root. If we look into this one, we can simply just kind of read any of these sections, and we will understand that it will be affected if all of these are equal. So, I mean, not equal, sorry, if all of these lines return true. So it should start with project root itself, and it should end with TF file. Or in case of Terragrunt, it should happen inside of project root, and file should be ending on HCL file. This is a very simple way. Maybe we'll need to update it, but not now. And another policy here is trigger dependencies, which is another type of policy called trigger policy, which is very similar. It will trigger this. It will trigger well, it will trigger this stack, yes, if yeah, this is if it contains this label depends on this stack. So as I showed earlier, if there is a stack which is specified inside of depends on, then it will trigger it as well. Okay, let's go to this. This is very kind of relevant. Policies. Policies, well, I guess they are 90% of value provided by Spacelift. Why I think so? Because you can actually control all aspects of the execution. So you can control from login phase, who gets login, what kind of stuff people can do with individual stacks, who can approve or reject certain things, who can actually run anything like run apply operation, for example, or run tasks. Think about task as like one off command, which we normally use CLI for example, to run Terraform import. You can specify that people are not allowed to run Terraform import, for example. Plan operation, who can run, what kind of things should happen when git push operation happens, and what happens when certain run finish. Then we need to decide whether we need to trigger something else or not. And task, what kind of one-off commands are actually allowed. For example, can people, let's say we make everything secure and then we allow everyone to run, I don't know, Terraform destroy. Well, probably not the best, not the best case, right? We made everything secure, but we allowed everything inside of task policy. So yeah, that's it. You can see how it works in details, rather straightforward way. I mean, if you have, I don't know, 1 week of your life to spend, you can read all of this, you can have fun and play with all of this. It's very powerful. If you don't have 1 week of your life which you want to spend on policies, there are a few things. First, you go to documentation for open policy. Anyway, you need to go there and you read it. You read it. It's huge. Yes, you finally finished it. And then you go to another section and you read it. So yes, it is huge. That's why let's close it. You can also learn OPA itself. You go to this academy, Stira.com. Stira is the name of the company who made Open Policy Agent, and they made a course where you can learn different basic things about OPA. Not many people knew about this course. I don't know why, but I think it is very useful to understand basics of it before you can start copy-pasting. So where you are copy-pasting it from? Exactly, you go to Spacelift Policies example libraries. There you can see 1, 2, 3, 4, 5, 6. Where is number 7? Where is init policy? Adam. Adam forgot to push folder number 7, which is init policy. But okay, anyway, you have a good understanding of what kind of policies are there, and you can read them, and you can see that there are quite a lot of them, right? So if you look into what kind of policies are provided, you can understand significant amount of use cases. For example, you will have to think about who should be able to let's say log into your system, because well, it is suddenly hosted somewhere and you need to control who has permissions to do what. So you will think about access policies here and who has more access to some protected stacks, and who has permission to override someone else's changes, and so on. As well as plan, really, you probably want to kind of disallow certain resource types. Maybe if you don't want OPA policies to be handled by Spacelift, for example, you already use conf test, or you use something else like Checkov or Terrascan, you can use Spacelift to do just minimum things of policies controlled by Spacelift. But then you can call OPA CLI inside of your flow, inside of your configuration. Let's say before you do certain things, in your pipeline, you can call OPA run and get some checks there. For example, don't allow resource type. Maybe it has nothing to do with Spacelift itself. Well, I think it does not have to be related to Spacelift, and that's why you already could have used conf test, for example, or Terrascan or anything else. Let's look into how this policy is written, and if you look something like this, you probably can get a decent understanding of what's going on, right? Well, the syntax is rather simple if you understand basics of OPA already. Okay, well, this was about policies. Now let's talk about workflows, and workflows specifically for this project. So imagine the situation where I have, let's say I have one repository, and this is now public, and people want to propose certain changes. So what they're gonna to do? Well, quite straightforward, right? They're gonna to open pull request, and this pull request will have to be evaluated somehow. We normally execute it in like all commits are executed, all PRs are executed, and then we know what exactly has happened there, what kind of changes are going to happen. And that's exactly what Spacelift can do. Well, I'm sure that now you're listening to this and think like, well, pretty much all systems can do this. And you're absolutely right. All systems can do this. But let's see how you can do this in Spacelift. So now if I go to my project GitHub main, right? So here, inside of GitHub main, this is configuration for one repository. And let's say I want to do some changes with labels, like issue labels, which are available inside of this repository. What I'm gonna to do, I'm just gonna to, let's say, add all issues will have possibility to be marked as bug, documentation, and so on. So I do some changes in the configuration, right? And what I would normally do, well, of course I can run Terragrunt apply locally. I'm able to do this right now because I have credentials to GitHub, and I can apply this now. Obviously, that's not what we're going to do now because, well, the topic of this episode is Spacelift. Again, I'm glad that you still remember what is the topic of this episode. So what we're going to do now? Well, we're going to make a branch, and we're going to say removed, no, actually updated labels, right? Updated labels. So I'm going to add this commit and into this branch, and I'm going to make a pull request. GitHub CLI works great. So, and I have just created a pull request number 2. If I open this pull request, you can see it now. So what you can see here? Well, first of all, this branch has not been deployed. What a shame. But then you can see that, well, it was so fast that Spacelift GitHub application, which is installed in this repository, was executed, and it was triggering GitHub main stack, where I can see that 5 to add, 0 to change. Well, I want to see more, right? I mean, I have no clue what is this 5. I can click here, right? Well, I should click here. And this is where I can see and I can scroll. Imagine that if you have long PR, not PR, lots of different changes, and Terraform plan is huge, you can scroll here and you can see, oh my god, this is like prehistoric age of DevOps. If you click show full screen, this is pretty much what you saw in terminal, and that's again a little bit prehistoric age. You can click here on the top, there is add or delete or something else. If you click add 5, that's what you wanted to see, right? That it's gonna to add these 5 labels. If you have hundreds of changes inside of add, changed, and deleted, it's much easier to review this way. So what you can do now, well, quite straightforward. You can continue pushing changes to that PR and talk to people and, hey, do that, change that. But what if you want to apply this change immediately and see how it's gonna to work? Well, you have a button called promote somewhere here, and where is it? Yes, it was here. So I have added one commit, and if I click promote here, what's going to happen? Exactly, it's going to apply this change. So it's going to apply changes in that commit. And let's see, waiting for some time, approximately 20 seconds. Actually, 20 seconds is very, very fast comparing to, well, comparing to you know who. It is very, very fast. This branch is being deployed. You can click show environment and you can see that something is happening. What it means is that I have just, if I click here, I have just specified that I want to apply this change, but I have not finished pull request yet. So I clicked promote, means that it was applied, but I can still continue reviewing this pull request. Why I would do this? Well, there are different cases. Sometimes pull request is so big that you need to apply it in certain phases or certain ways. But most frequently, you are not going to promote change from merge request, which is not complete yet. So imagine, let's go back here. Let's do some more changes. Let's say disable certain type of issues, and I make another git push. So I have just committed some more changes, and waiting for 20 more seconds, and I will see same result here where it says that 3 more to add. And finally, as you can imagine, I have reviewed this pull request. It looks good, right? Does it look good? Yes, looks good. And what I can do, well, I can just click squash and merge. And that's where like most of magic happened, right? So I click squash and merge. Now this branch is gone. And now if I look into this stack, I can see that that this PR was merged, and it is actually going to be triggered, and it's going to be applying the change, because there were changes inside of project root. So finally changes inside of my god. So finally changes inside of project root, inside of master branch appeared. So that's why they will be applied. So very straightforward, I would say, but that's not what is the most exciting thing. While working with open source, and actually with many other type of companies in general, you would have to have a possibility to separate access between, let's say, everybody can run plan, because plan is read-only operation, nothing bad should happen, and that's why you want to have a plan available. But at the same time, you would like to have Terraform apply, potentially deleting or updating infrastructure. And that's where very helpful thing in Spacelift is. Well, I don't use it here, but sometimes I do. This GitHub token, or pretty much any secret value or any other environment variable, can be different. It can be, if it is written like this, then it is going to be available for Terraform plan and Terraform apply. But as I said, Terraform plan should have significant less GitHub permissions, just because in case it is leaked, people will be able to just read something. But I don't want people to delete GitHub repositories, for example, because they got access to this GitHub token. And the way to split this environment variable is to prefix them with RO as read-only, or WO as write-only, or write operation, or read operation. So then RO underscore GitHub token will be used for read operations, and that's exactly what you will be able to give GitHub read-only permission, and write-only will be much more powerful, where people will be able to, not people, where system will be able to consume this token and do applies. All other values here are computed, because they will be computed only in runtime by Spacelift. When Spacelift, for example, will access AWS account, it will assume role, and it will set these variables. And same for Spacelift environment variables. All this information about account name, commit, branch, and so on, you can use inside of your Terraform configurations quite natively, because this is already TFRs. Okay, let's see what else I have. Right. Yeah, and one more case, which, like, the way I used this was the following. I like to have, like, if you've been watching these streams before, you like to see that I use Terraform CLI or Terragrunt CLI quite frequently. I don't think I ever logged into any Terraform automation system to do something something real, at least during live streams, right? And the reason for me to do that is that I like to do it much quicker. So let me show how I can combine these two things, where I want to use Spacelift policies, because imagine that there are 25 policies attached to a bunch of different stacks. Currently I have just 2 policies attached, but I could easily attach 25 more. And I want to be able to run it from my local machine. So of course I can run Terragrunt apply, but to do that I need to have access to all of my secrets. If I don't have this possibility, then it's not going to work. Then I need to commit, open pull request, wait for some time, fix something, and it's going to be slow all the time. So let's see. Git pull. No, actually, yeah, we can do. It doesn't matter. Let's see. Now I go back to master branch just for fun, actually. And what I want to do here is spacectl, stack local preview command. So what this command will do, if I look into the configuration of this stack, it is enabled here. So it means that all stacks which I created, they can be invoked locally, which means I don't have to commit code. I can execute something very dirty and preview it, how it will behave, how my policies will be invoked, whether it will allow me to do certain things. But me as a developer, I don't have to have full access to GitHub even right now. So all I have to do is to configure my spacectl command with certain spacectl credentials and set it as environment variable and run this command, spacectl stack local preview, for this GitHub main. So what's going to happen? As you can see, it is uploading local workspace, which is 3 kilobytes. It took 200 milliseconds. And it is actually triggered, or it is performing live run, which I can see if I go to this URL. But, well, I don't want to go there. And then the rest of output is from Spacelift. So now Terragrunt is executing not on my laptop, but somewhere outside. As you can see, it is doing pretty much the same thing. And what is it? This is warning. Well, I don't care about it. And no plan policies to evaluate, and segmentation fault. Well, that's life. You do something, it works, and then segmentation fault. Anyway, you can imagine that it worked. It literally worked yesterday when I was preparing for this. But I can see that it was successfully finished. So at least segmentation fault happened at the end of this execution. So nevertheless, you can get the point, is that when you run something, when you do changes, let's say somewhere here, and you want to see how they're going to work, just for fun, let's add time. And it's going to be uploaded. Maybe it will succeed now, who knows. And it's doing all of this pretty fast. Some of this can be optimized, of course, if I can maybe cache or maybe skip some. Yeah, I can probably skip some Terraform init commands, but anyway, the point is that 23 seconds, right? So yes, it took 23 seconds to upload my changes somewhere then the Terragrunt plan was executed, and then it tells what's going to happen. If I can do the same stuff here, well, I can probably do the same. Time plan. So what's the difference between me running this stuff locally, which obviously took less than 23 seconds, and I guess my wrapper cuts everything from the Terragrunt. That's why I don't even see time at the end, but nevertheless, it is faster. The biggest benefit of this is that when I use spacectl command, spacectl stack local preview, is that the same set of policies are being executed and being enforced on that machine. So if I don't have permission to execute Terraform plan, then I wouldn't be able to use stack local preview because, well, it is denied for myself just because it is lunchtime, for example. Isn't it good policy? Well, and there are a little bit more things which I wanted to show, but I don't have time right now. Let me just kind of conclude and summarize what I showed today and what I want to show next time. So today I showed how the spacelift-meta can be configured as code pretty much statically, right? So here I just specified spacelift stacks, assign couple roles, policies, and that's it. And I also showed these different ways or different types of policies. I didn't write any policies because, well, it's probably much more complicated than just live stream, so it will take a little bit time. But one thing which I want to kind of highlight is that when you have all of your configuration in like as code for cloud resources or for GitHub resources, it doesn't really matter for what. You can use the same structure and configure Spacelift stacks as well as a bunch of other resources without touching them. So if you use Terraform, it's even simpler than with Terragrunt because, well, Terraform is natively supported by Spacelift, but Terragrunt is supported well as well. So next time I think I will show a little bit more of how to render Spacelift stacks a little bit more dynamically from real dynamic set of modules. Yeah, not modules, of Terragrunt layers. How it's called even in Terragrunt? Oh, I forgot. And I want to show a little bit more like end-to-end flow, thinking about like real changes happens, people open pull request, and then these people will be able to see changes. I mean, there are limited group of people from Terraform AWS modules who should be able to do changes there. So we'll need to figure out how to do this. But all of this will be next week. On this note, I want to say that that's it. Well, no, this is it. No. Thank you very much for your time. Oh yeah, oh my god, there is a question. Sorry, there is a question. Are you able to apply only parts of resources on Spacelift? Well, that's a good question. You can do everything what you want if you use, no, where is it, this? If you use runs. No, if you use, sorry, not runs, main, if you use task. So here you can run anything you want. So you can run Terragrunt, apply, target, and then module, blah, blah, blah. This you can write, but that's pretty much it, from what I understand. How you can do this. Yeah, I think that's it. I'm thinking whether you can do crazy things like set an environment variable. Does it even make sense? Because there are some environment variables. No, what is it? CLI, args, something like this. And then apply. And then here you can say target module. Does it even work? I mean, if you set this as an environment variable, then it will be available for Terraform internally. But it's ugly as hell, so I wouldn't do this. In fact, I don't think you should be doing this. But it's a pretty good question. Well, feel free to ask this question someone from Spacelift, not me. Okay, thank you very much, everyone. Hope you learned something. See you next week.